Before we start coding with LINQ, I want to make sure you're familiar with a couple C# language features. This will ensure that you're able to follow along well when we start coding and going through documentation. The two features are extension methods and lambda or anonymous functions. These will come up a lot. Let's start with extension methods. Extension methods are implemented as static methods within a static class. The first parameter of an extension method is preceded by the this keyword, indicating that the method extends the type of that parameter. Despite being static, extension methods are invoked using instance method syntax, making them appear as if they are part of the extended type. Extension methods are only accessible within the scope of the namespace in which their containing static class is defined, requiring a using directive to be used. Let's go over a simple example to make some sense of that last slide. Note that first we said that the extension method would reside in both a static class and that the method itself would be static, and you see that here. We also said that the extension method, in this case called reverse, the first parameter to it would have the this keyword at the start. In this case, we're extending the string class, so we see the string as the type, and then finally the parameter name as you're used to in any method definition. In this simple method, we are going to reverse the order of the letters in the string. We start by converting the string to a character array. We leverage the array class's built-in reverse method to reverse the order of those letters for us. And then finally, we return a new string from that reversed character array. If you didn't know, the string class has a constructor overload that can construct a string from a character array. Maybe you're not used to building strings that way, but you can. So now that we have this extension method defined, you can go ahead and start using it. Nothing new here, right? You have a string called original string where we're just going to make up a typical hello world text to learn with. And then the extension method is actually used in the next line here. We have reversed string equals original string dot reverse. Like the last slide said, note how we're using this like an instance method and not how static methods are normally used. I have described the static keyword in the past very simply as, well, you can think of it as turning object-oriented programming off. So normally when we invoke static methods, we will list the class name, dot, and then the static method name. But that's not what we've done here. We've invoked the reverse method on an instance of string called original string. So hopefully that's clear to you from the last slide. And then finally, our last bullet on the last slide noted that you would have to include the name of the namespace that this string extensions class resides in this usage text below. This is just a snippet, but somewhere in that file at the top, it would say using whatever the name of the namespace is. Before ending our discussion of extension methods, I wanted to leave with a few notes. I didn't want you to think that extension methods are only something associated with LINQ. You can use them however you like. A couple nice things. I will say they're good when you want to extend types that you don't have control of because the source code isn't yours. For example, with types that are built into .NET, like we saw with string, or if you're using a third-party library. They can also be nice that if you use them well, you can use them across different projects. So let's say you really liked that reverse method for strings. You don't have to do that in just your current project. You could have that available in any future projects as well. In general, I'm not a big fan of extension methods and don't use them myself. To me, they give a bit of a code smell. It almost feels like if something should have been, in code that I control, if something should have been defined in a class, then I would modify my code to make my code offer that feature in that class. You should note that you can only access public and internal members of derive types with these extension methods. You can't access private or protected material. And there's a potential for overuse once you sort of open the door to this that can lead to bad code. So I'll leave it up to you whether you think extension methods are a good practice that you want to incorporate on your own beyond just what we're going to do here with LINQ. Okay, let's move on to lambda functions. These are a concise way to define anonymous functions, that is to say, functions that are not named. This name lambda apparently comes from lambda calculus, and that Greek letter lambda was apparently used to represent anonymous functions in that branch of math, so it's seemingly an appropriate name for this. Lambda functions also allow you to write inline code blocks to use with delegate types. And if you're not familiar with delegates in C#, they basically are object types that encapsulate methods. So you can think of this as a way for you to pass a method to a method. Let's go over some key features of lambdas. First, you have the lambda operator itself. It looks sort of like an arrow. It's the equal sign followed by the greater than symbol. This separates the input parameters from the method body. Input parameters go to the left of the lambda operator. Note that parentheses may be omitted when there's just a single parameter. We'll see this a lot in LINQ, and since we're all about being concise with lambdas, it's nice that they give us this option to not have to type that out either. The method body goes to the right of the lambda operator. We're typically going to use a single expression, but you can also write out a series of statements like you're used to with traditional named functions. And again, the emphasis here is to be concise, and this is especially useful for one-off type logic that isn't going to be reused. The idea being if we had some kind of logic that we were going to reuse a lot, then it would probably be worthwhile to write out a traditional named function for it and use it in other places of our code. There are two classifications of lambdas. We have this idea of an expression lambda versus a statement lambda. And I showed you the syntax for the two here. Hopefully you can see the subtle difference is in the body or on the right side of the lambda operator. We see for the expression lambda, you get a single expression for the body, whereas in a statement lambda, it's more like those methods that you know where you write a series of statements ending in a semicolon like you normally do. Because expression lambdas are useful for LINQ, that's what we're going to be dealing with in this course. But I just want you to be aware that there's another type. I thought it'd be helpful to go over a quick lambda example with you as well. Well, in fact, we have two here showing both the expression lambda and the statement lambda. Again, we're going to be focused on the expression one. Don't be alarmed if you're not familiar with this func int delegate type syntax. What I want your attention on is the x with the lambda operator arrow and then an expression. So the x, again appearing without parentheses because it's a lone parameter, is the input, which is an integer, and which can be determined by this type. And then finally, you can see that we're just returning the integer times itself, or in other words, we're squaring it. So that's why they named this one square. And then they show you if you write line calling that method with the value 5, it squares it and you get 25. Hopefully that's clear. And then I won't talk long about the statement lambda. It's kind of the same thing, but note how now we have, like we're used to, we have some curly braces defining a scope, and then we're writing out what value to return. In this case, they give you a list of the numbers 1 through 5, and they want you to count which ones are even, right? This n modulo 2 equals 0 is just a way in code to tell if a number is even or not. Again, I'm trying not to get too far off topic, but yeah, that's what modulo, it performs a division and tells you what the remainder is. If the remainder is 0 and dividing by 2, you have an even number. And so you can see if you invoke that method, The count is 2 because the values 2 and 4 would register as evens, whereas the other three values would not. So, but again, you can see the lone parameter here, n, um, is not in parentheses either because it's a single parameter. And yeah, you got the lambda operator there. Hopefully that example is helpful. Like extension methods, lambdas are also not just for LINQ. I just listed out a few examples here of other places where you can encounter lambdas. So delegates as method arguments, we mentioned that you can pass a method as a parameter to another method. These come up a lot in event handling and asynchronous programming in the form of callback functions.